This time we want to look at the sum of a geometric progression. We've looked at finding the terms of a geometric progression and problems that we can use the a times r to the power of n minus 1 formula. Now what we want to do is have a look at two different formula. They do the same thing, all will depend on what the value of r is. So we're going to find the sum using either of these formulas. So the first one is a outside of r to the power of n minus 1 all over r minus 1. Now that's going to exist if your ratio is greater than 1. So if it's not greater than 1 and it's less than 1, so it's either a fraction or it's going to be negative, we're going to swap the 1 and the r around. So it's going to be 1 minus r to the power of n over 1 minus r. So it won't matter which, it doesn't change too much. It just changes its position there. So you're keeping the same value, so you make sure the values are going to work properly. Notice r is never going to be equal to 1, because if it is equal to 1, all we've got to do is count up how many terms and multiply it by our value of r. So it's the terms aren't going to change. Like if your common ratio is 1, your term in each time is going to be the same, so it's not going to matter. So also it's not going to be 0, because you're not going to multiply by 0 to get another term. That's not going to give you a series at all. So there's your two forms you're going to use in all these questions. So in the first one here, what we've got to do is identify, we want the first 12 terms in the series. We want to identify what a is, what r is, and what n is. Well, n, we're told, is 12 terms, so that's okay. That's not too hard to find. But also now we can see that a is going to be 1/6, so that's easy to find as well. R is probably the trickiest part. We're going from 1/6, 1/2, 1.5, and so on. So our terms are getting bigger, so it should be a ratio that's greater than 1. Again, to find the ratio of in any of these series, take your second term, divide it by the first term. And a half divided by 1/6 gives us 3. So n is 12, r is 3, a is 1/6. Apply the formula, and we're using that formula where r to the power of n minus 1 and r minus 1. So we substitute our values there, put it into the calculator, taking care again, because you've got fractions, you've got powers, you've got fractions and division there, so be really careful. And it said before, like our terms can get really big, but our sums get really big too, so even quicker, because you can start to add really large numbers. In the next question, we've got the sum the first 10 terms. We look at our series, 6, 24, 96. So that 6 times 4 is 24. 24 times 4 is 96. And doing the division, go backwards. So we see that our ratio is 4. So we're going to use r to the power of n minus 1 over r minus 1. A is 6, n is 10. Do the substitution. And 10 terms of this series, it doesn't look very big to start off with, ends up being over 2 million. So don't be too worried if you're getting large numbers, because it will add up. It can add up really quickly depending on what our ratio is. This one here is a little bit different. If we have a look, we've got 7 minus 1, then positive 7, minus 49, positive. So that occurs when we start to get a negative ratio. So because 7 divided by minus 1 is minus 7. Minus 49 divided by 7 gives us minus 7. So note that we've got a negative ratio, so we've got to be really careful in this situation. Negative 1 is our first term, negative 7 is our ratio, and we want 8 terms in the series. This time we've got to use the formula, so we've swapped our formula around, 1 minus r to the power of n over 1 minus r. So we've put that in. Now you've got to be really careful with your calculator here. Use the brackets as we've got them there. If you don't, then you might find yourself in a bit of trouble. You might not, but it depends on your calculator and how it's working. So I would put it in my calculator with the brackets there. So it's minus 7 to minus 7 all to the power of 8. So I have that bracket there. So just be really careful. Otherwise, you might find yourself with the wrong answer from a correct working, but you never know when you want to lose marks there. You want to make sure you're getting it correct right through to the end, not throwing your answers out. In question 4, 9 terms, again we've got a negative ratio, 8 minus 24 plus 27 and minus. So notice with a negative ratio, every second term is changing. Every time it changes its sign. So minus 24 divided by 8 gives us minus 3. So you've got 8 as your first term, minus 3 is your common ratio, and 9 terms. So again, we substitute, we're using the 1 minus r to the power of n over 1 minus r form. So we substitute in, be really careful with the two negatives there, and that will give us the answer there from our, just again from our calculator. Again, negative ratios, be careful. 3/4 minus 3/8. Notice this time our ratio is minus a half. So that's going to be, you've got to be careful there. First term's 3/4, n's equal to 12. Do our substitution. You can leave your fraction here as a decimal if you like. It doesn't really matter what you put your answer as. So as long as it's a correct answer, as long as it's equivalent. Again, take care putting these values in to your calculator. Use the brackets, especially with the negative there. Use the brackets and be careful about all those fractions. Okay, this time we're told to evaluate this series, but we don't know what the actual number of terms in the series is. So this is a problem that's twofold. Firstly, we've got to find out how many terms there are. We know A, we know R. We can see what that is. Like 6 times 2 is 12, 12 times 2 is 24, and so on. But how many terms does it get to go to 768? We know that 768 is a term in the series. So 6 times 2 to the power of n minus 1 would equal 768. So divide by 6 gives us 2 to the power of n minus 1 is 128, or 2 to the power of 7 is equal to 2 to the power of n minus 1. So this n minus 1 must be equal to 7, which means n would have to be equal to 8. If you wanted to solve that using logarithms, okay, from this point, go back and use the logarithms form there. So your power there is equal to log base 2 with 128. The only problem is with this one, you're going to have to use a change of base law. Your calculator can't do log base 2. So change it to whatever log base you like, but then you've got log of 128 over log of 2 would give you the 7. So if you throw it on your calculator, no matter whether you use log base 10 or log base e, and then n minus 1 would equal 7 and n would equal 8. Not hard to do that. Most of these ones will be okay. You won't have to use logs for a while with these types of ones. So now we've got that there's 8 terms in this series, because 768 is the 8th term in this series. We can find the sum to 8 terms. So 6 outside of the 2 to the power of 8 minus 1. So there's A, there's R, and there's N. Over the R minus 1 gives us that sum there. Again, this relies on us finding what term in the series 6,250 is. We can see A is 2, R is 5 when we do our calculations. Set our formula up for the term of a series. We're solving down. We know 3125 must be giving us a whole number. It can't give us, if it doesn't give us a whole number, well, it doesn't work. It doesn't give us a series, so it can't be a term in the series. So we can play around. We can have a pretty educated guess that it's going to get around 5 or 6. So 5 to the power of 5 is 3,125, and that means n minus 1 would equal 5. So that would allow us to get n being equal to 6, because our powers must be the same because our bases are the same. So then again, apply the value of via all those values to the equation, the formula, and you're able to calculate that 7,812. Again, evaluate this one. This one's a little bit different again because you've got the negatives in there. So that means the common ratio is a negative value. So again, we're still able to apply our formula for the term. We know 384 must be a term in the series. And we've got the minus 2 to the power of n minus 1. Again, this time we've got to have minus 2 to the power of what would equal 128. A little bit of a trick for young players is that because it's going to be a negative there, and it's minus 2, it'll have to be an odd power. So that limits your choices. So it either has to be 3, 5, 7, 9. So 7's a nice choice here. And so seeing we've got the minus 2 together, n minus 1 must equal 7, which leaves n being equal to 8. And then we're able to substitute the values. So notice we're using the 1 minus r to the power of n because r is less than 1 in this case.